this lecture we will going to talk about the signed and unsigned number.
We have to talk about the signed binary numbers. That were talking about the positive numbers, and we were talking about the negative numbers. So right now what we have seen that whenever we are writing a number 0111 or 1001, so what is the sign bit? So sign bit means as a sign represent that either the number will be positive or the number will be a negative. So let's say if I am writing this like V, so I say plus volt, okay, and if I write this minus volt, so I can say that my waveform is like this, plus V and minus V. So we can see that voltage, if I have represent the voltage, I have represent the voltage in the positive form and the negative form. That means that whenever we are performing some operation in the digital also, we are doing this thing in the digital also, so we have to represent the number either as a positive number or a negative number. In the mathematics, what we are doing, we are using this plus symbol and the minus symbol. Okay, we are using this plus symbol and a minus symbol. But when we are talking about the digital do not understand this plus and minus. Okay, it only understand your zeros and one, nothing than this, either 0 and 1. So now the question arises that if it understands 0 and 1, so how we can represent the number as a positive number or a negative number? What we can say that we have got a numbers, and that number will going to decide that whether the number is your positive number or a negative number. And why we are also going for this? Because whenever you are seeing the circuit, let's say we are talking about your laptop or a mobile, all this operation has to be performed on your laptop and mobile. So we have got a limitation of a hardware. So we require some techniques so that we can use a limited number of a hardware and we can perform all the arithmetic operations. We have got a CPU, and in CPU we have got ALU, arithmetic logic unit. Whatever the arithmetic operation or the logical operation has to be done, that is to be performed with the help of that. Okay, and that is a very small unit that is available in the computer. So what we require, that small hardware should be capable of doing all this operation. We can say the convention what we are using for the sign bit is 0 for the positive. So whenever we are talking about the sign bit, we always say that 0 for the positive and 1 for the negative. So 0 is for positive and 1 for the negative. But another question that comes is that how we will going to identify? Is every number will going to be identified as a negative number, or the number will going to be identified as a positive or a negative? So let's say I take an example, 101001. Okay, let's say 01001. So can you tell me this is a positive number or a negative number? Now listen to this concept clearly, why I have written this. So right now I am not told you that whether it is an unsigned number or a signed number. I have told you that whether it is a signed number or an unsigned number. If I am representing this as I can represent it as a signed number, or I can represent it as a unsigned number. Until unless I am not saying it is a signed number, by default it will going to be considered as a unsigned. Again I am repeating, until unless it is not written or it is not defined, the bit which is given to you is a signed number, by default it will be always be considered as a unsigned number. So when we take it as an unsigned number, the equivalent of this is 9. You cannot write positive number. And if I am writing it, if I am taking this number as a signed number, okay, if I am taking this number as a signed number, so what I am doing, I am writing 001, then the leftmost digit, the leftmost significant digit, I can say this one, this will going to represent, this is 0, so 0 will going to represent it as a positive. And what is the rest equivalent of this? The rest equivalent of this will going to represent your decimal equivalent. So what is the decimal equivalent of this? 9. So it will going to represent your plus. So until unless it is not being represented, if I am giving you a number 01001 and if you say it is a positive 9, so it is a wrong answer. Okay, it is not a positive 9, it is only a 9. When I say that I am giving you a signed number and then I am asking you that whether this is a 9 or a positive 9, then it is a positive. So let's take another example. Again, I will going to take one more example. 1, 1, 0, 0, 1. Now again, if I can go again in the two way, I can use a signed and an unsigned. So I am using S for signed and US for the unsigned. Okay, so if I talk about the unsigned, what will be the answer? For unsigned, it will be a 25. And for the signed number, I will going to write it as like this 1001. And then what I will going to do, I will take this one. So this will going to represent my negative number. And what is the decimal equivalent of it? So let's say decimal equivalent of this is 9. So it will going to represent my minus 9. So until unless the number is given to you, you will going to say that when the number is given to you 11001, so this same number is representing you as a 25 also, and it is also representing you as a minus 9. Okay, so the thing comes into the picture is that when anything is being given to you, okay, until unless it is not been defined that it is a signed bit, it will by default it will always be considered as a unsigned bit. Okay, let's say I have a number 9, okay, and I want to represent it with the help of a 8 bit. I have to represent this with the help of a 8 bit. So how I can represent? With the help of this, I can represent it as a 00001001. So we have represented this as a 9. If I replace this 0, okay, if I replace this 0 with 1 and rest I copy this number, okay, rest I copy this number like 0001001. Okay, so I'm saying let's say 9 and we are talking about the sign bit. So what it will going to become? It will going to become a minus 9. We have taken a minus 9 and we have represented it in the sign magnitude. With the help of a sign magnitude, we have represented it. If now I ask you to take the ones complement of it, I want to represent a number and I want to represent it into the ones complement. So what I have to do, I have to take a ones complement of this. So I will copy this one only here and I will going to copy the rest number. So the rest number will be 1110110. This will be the representation of a minus 9 in a ones complement. So I will going to say this is a signed ones complement. And if I want to add plus 1 in this, I will going to add plus 1 in this. I will copy this one here and I will going to add a plus 1 here in this. And if I get an answer like this 1110111, so what will be this? This will be the signed 2's complement. We have got only one way of representing the plus 9. However, we have got a 3 way to represent minus 9 when we are talking about the sign magnitude. Okay, so whenever we have a complements of a positive number in plus 9, whether it is a sign magnitude or a sign 1 complement or a sign 2's complement, it will going to represent a same number, okay, plus 9. But when we are talking about the minus 9, that is a negative of a number, at that time you will going to see that we can represent the negative number into a 3 format. And you can see the sign magnitude, sign 1's complement and sign 2's complement have got a different variable.
As you can see that the sign magnitude, sign 1's complement and sign 2's complement, all these have got a different bits available at their different positions. I hope you have enjoyed this lecture. Thank you everyone. We will see you in next lecture.